relation. Foreign key is a candidate key of a relation A situated in the relation B, and the database is a set of relations. Now, the comparison between the modeling approaches. Semi-structured models have more flexible than relations. Nevertheless, the relational model is still preferred because databases are large and the efficiency of access to the data, efficiency of modification to data, and it is very easy to use. These all goals can be achieved with the model, particularly in the relational model. A relational model provides a simple, limited approach to structuring data, yet for reasoning flexible, so anything can be modeled. Actually, a relational model is help to convert the real world problem into the computerized way. So, a limited yet useful collection of operations on data. So, these are the levels of abstractions, means once the database is stored, how we can view the data. So, we can view the data in three ways. The first of all, you can see here is the DB. DB means database, where all the data is stored. This is known as the DB. This DB is directly interacted with the physical schema, means how actually bits and bytes are stored in the table, how efficiently indexing is done, how efficiently storing of the data is done, is all concerned with the optimal physical schema. How optimally data is stored in the database is all the functions of the physical schema, and this physical schema actually are directly connected with the database. Then comes the conceptual schema. What are the logics applied on our database, how we see the database, this is the conceptual schema, like in the form of tables, in the form of hierarchy, in the form of networks. This is all at the conceptual schema. And the final is the views. What are the user requirement, or any non-technical person who are working upon the data, who have only a minimal rights to change the data, are the views of the data. So, these person we are seeing, these are the view 1, view 2, view 3, means different type we can see our data. And how actually data is stored in the tables is defined by this conceptual schema, and the physical schema deals with how bits and bytes stored in the database. So, view describe how users see the data, and the conceptual schema defines the logical structure of the table. This conceptual schema describes the logical structure of the table. Then comes the physical schema. This physical schema describes the file and indexes used. Indexes is used like the address of the data, where the address where the actually data is stored in the table is the indexes used to locate the data. And sometimes it is called the NSI or the Spark model, which helps to store the data, then conceptualize the data, and then to view the data. These are the levels of abstractions. Now, the big breakthrough of the relational model is data independence, means we have the data in three views, view 1, view 2, view 3. If we slightly change one view, whether it affecting the another view, this is the one of the question कि अगर ऐसे physical schema change करिए, is it affecting the conceptual schema? If we change the conceptual schema, is it affecting the views, view 1, view 2, view 3? So, this is the big breakthrough of the relational model, or is the data independence, means when the application should be insulated from how data is structured and stored. Means once the data is structured and stored, insulated from other. Means at a one level we are storing the data, we are structuring the data, we are using the data without affecting the another view, is the data independence. Here you see, you are altering this physical schema without changing this conceptual schema or user, without changing this user view. This is known as physical data independence. And logical, protecting the changes in the logical structure of the data. You are changing the physical schema. This is known as logical data independence. And when you are protecting the changing in the physical structure of the data, which all have to be done at conceptual schema, this is known as physical data independence. Like when you are changing this view level without affecting the physical schema with the help of conceptual schema, this is known as logical data independence. And when you are changing the physical data, the user view without altering this physical schema, this is known as physical data independence. Why are these particularly important for database? Why we need this? Because as the requirements of the user are changing day by day, the requirement of the user changes. Once the user say I have to do the work like this, and at the other moment see the data at another view, so it has to change the views, but we should not alter the database at same time. So we need this logical data independence, so that we can alter the one view without affecting the other. So why we study the relational model? Because this is the most widely used model currently. DB2, MySQL, Oracle, PostgreSQL, SQL servers, these all legacy systems use the older models like IBM's IMS information management system. The IBM have developed in 1960s the IMS, that is information management system, and the IBM uses that system, that legacy system. But nowadays we have Oracle, we have MySQL, we have DB2, so that we can easily put on the queries and fetch the result from the database. And the other advantage of this is object oriented model, that is all the real world problems are easy to modify or modeled into the object oriented concepts. So these object oriented model, Infomix, IBM DB2, Oracle 8i, nowadays 9i, 10i is also available there, which helps to do the things in the object oriented or the object relational models. Then there is a XML, that is the semi-structured models, which are the emerging models which helps a little bit programming, and the most web-based applications can be generated by this XML. Now in the revision terms, a relational database is a set of relations, and the relation made up of two parts. The one is schema. Schema is what? Description of the relation. Schema specifies the name of a relation plus name and the type of each column. Like here you see student is a relation. SID, student ID, it is of string type, matlab character type. Name, character type. Login, character type. Age, character type. Then GPA, that is real type, integer data. So when you are defining the attributes with their data type and with their name of a relation, we said it is a schema, description of the table. And the instance is at a one moment of time, what are the rows and columns in the table is known as the instance of the table. Means what is the cardinality of the table and what is the degree. Cardinality means how many records are stored in the table is known as cardinality, and how many attributes are there of the relation, this is known as the attributes or fields of the table. So, instances at one particular time, what are the rows and what are the attributes, this is the instance of the relation. So, a relational database consists of schema, description of the table and the content of the data. What are the name, roll number, GPA, age you have entered in the table. This is the instance of the table. Can you think of a relation as a set of rows or tuples, that is all the rows are distinct, that all, it means when there is a no duplicacy of a data, we said it is the data is integrated or concrete. Here we took up an example of university database where the conceptual data is students, SID, name, login, age, GPA, and there is a courses, course ID, course name, credits, and there is enrolled, SID ID, student ID, course ID and the grade. And at external level, this is only a course information and the one possible physical schema. Relations stored as a unordered files and indexes on first column of the relation. So, this is how the conceptual schema defines. When there is a student, student ID, this is the conceptual level. At external level view, it is the information about the course and the courses and the enrollments, and the one possible physical schema is relations stored in unordered files. Here is a one instance of the student relationship. Here you can see student ID is a primary key because it uniquely identifies this attribute of the column. This student ID is the primary key. And how many attributes are there? 1, 2, 3, 4 and 5. Student ID, name, login, age and GPA. So, there are 5 attributes in the relation student. And how many records are there? 1, 2 and 3. These 3 record becomes the cardinality. So, cardinality is 3 and the arbitrary or the degree of a relationship is 5. Why 5? Because there are 5 columns, 1, 2, 3, 4 and 5. These 5 attributes, so the degree of the table is 5. 3 tuples, 1, 2 and 3. 3 tuples, 3 records, so cardinality is 3. And this student ID uniquely identify the relation. So, this SID is a primary key. The question arises here, do all values in each column of a relation instance have to be unique? So, the answer is yes, because if student ID is a primary key, there should not be any duplicacy of the data. So, cardinality is a schema property and attribute is a schema property. No, cardinality is not a schema property, cardinality but attribute is the schema property. Now, to alter the data, to insert the data, to modify the data, we need a language from where we can insert the data, we can retrieve the data, fetch the data. This SQL is structured query language. It is a integralatic standard for the data, which stand for structured query language. This structured query language is defined by the 2 sub languages. The one is DDL, the first is data definition language. This DDL is used to create the data, modify the data, delete the relations, specify the constraints. Constraint means what the data can be inserted, what data cannot be inserted. These are the specified constraints. It also helps to specify the administrator rights. who are the administrator users, what are the security etc. are applied on the data. And the other is data manipulation language. This DML is help to modify the data, like specify the queries to find tuple that satisfy the criteria, add the data, modify the data, removes the tuple etc. This DDL deals with the schema of the table. This DML deals with the cardinality of the table. Now here are some example of DDL. Create table. What are the syntax to create the table? Create table, table name, whatever the table name you want to give, then the field, then their domain. Like to insert the data, command is insert into table name, then fields name, whatever the fields name, and what the values that should be assigned to these field names here comes in this column. Then this is the syntax to delete some data from the table. Delete from table name, where condition, like where city is equal to Mohali, where name is equal to this, where age is this, to delete those type of data. Then update name, set field name is equal to value, where condition, to change the data or modify the data. This select command is used to project the data to give the view of the table. Like in this select field, suppose you select the two fields from a table, where from table name, where condition, like to satisfy the two or three conditions, it will give you a view of the table according to your requirement. Then there is a creating the student relation. Here is one more example. Type the domain. Domain is restricted set of values of each field is specified and enforced by the DBMS. For example is create table students where SID char 20. One attribute is student ID SID, domain is character type, and the size is 20. Then name, character type, size is 20. Login, character type, size is 10. Integer type, and GPA is float type. Another example is enrolled, where student ID char 20, CID char 20, and the grade is char 2. Here you can see, by inserting some value, insert into students SID, name, login, age, GPA, these 5 attributes and their corresponding values. Student ID is 53688, name is Smith, login is Smith @EE, and the age is 18, GPA is 3.2. Here you see each values defined in a single quote and separated by a comma. Each value is enclosed in the single quotes and separated by a comma. It will insert this record into your table students. And now delete. How to delete? Suppose I want to delete all the tuples satisfying where name is equal to Smith. What I have to write? Delete from table. Table what is? Students S, where S dot name is equal to Smith, where name is equal to Smith, it will delete the value Smith from the table. These powerful variations of these commands are available. Here are some keys. You see, this student ID is the primary key of this table, and this student ID is the primary key of this, and this is the primary key of this. This primary key of one table, if become the attribute of another table, this is known as the foreign key for the student table. Now, what is the primary key? A set of field is a super key if no two distinct tuple can have the same value in all the key fields. Now, the candidate key, a set of fields in a candidate key for relation. If it is a super key, no subset of a fields is a super key. What if it is greater than one key of a relation, then we said it is a primary key. Here you see this CID, student ID, is the primary key of one and attribute of other. This CID is known as the foreign key of this relation table. This is known as integrity constraint. Here you see note possibly many candidates keys specifying using the unique one of it chosen as a primary key. These keys must be chosen carefully so that student can take only one course. No two students can be enrolled in a same course. So this is the wrong. Why it is wrong? Because in this student ID cannot be, no student can be applied in the same course. So we have to describe the CID, student ID, and the course ID as a primary key rather than to make it a candidate key. So this is the concept of foreign key. Set of fields in one relation that is used to refer to a tuple in another relation must correspond to a primary key of the other relation. So this is the logical pointer, and if all the foreign key constraints are enforced, we said referential integrity is achieved. This is how to define the foreign key in SQL. Create table enrolls SID char 20. This primary key SID is where foreign key SID references student. So this is the syntax to create the foreign key in the table. So this is the student table. Here is the student ID, and this SID is the foreign key for the student which is referenced from the student. So this is how foreign key can be created. How do we enforce the referential integrity? Consider the students enrolled. SID enrolled is a foreign key. This is the how. But what should be done if enrolled tuple with a non-existent student is inserted? We have to reject. We cannot insert the data. In this, you can say here this data is not present in this. So this data is rejected by this table because this is the foreign key of this table. Only the data which is present corresponding to this table can be enforced in this table. So what should be done if a student tuple is deleted? Also delete all the enrolled tuples that refer to it, and disallow deletion of student tuple that is referred to. Set CID as enrolled tuple, that is very difficult to achieve. In SQL, the enrolled tuples are referred to it to special values null or not applicable. Similar issue arises if the primary key of a student tuple is updated. Integrity constraint is same if the values are defined and ICs are specified when the schema is defined. A legal instance of a relation is a one that specifies all the specified integrity constraints. If the DBMS checks IC, that is integrity constraint, stored data is more faithful to real world meaning. It helps to avoid data entry errors as well. So this is all about the data we have studied. A tabular representation of data. It is simple and inductive. Integrity constraints are maintained. Powerful query languages are there, DDL, DML, which helps to manipulate the data.